Today in class we worked on finding the surface area of cones and pyramids. This cone, or this is actually two cones, right? It's a composite figure. It's very similar to some of the work we did earlier this year with two-dimensional composite figures, where we have to add the areas of the shapes. We broke up the two-dimensional figure into shapes and found the area of each individual shape, and then added the areas of those shapes to get the total area. Here we're doing it with surface area, but there's something tricky about this. You have to realize something about this. So let's talk about this first. The surface area of a cone is equal to the area of the lateral area, which is the area around this part of the cone. Like if it was an ice cream cone, it'd be the part you'd be holding on to, plus pi r squared, because the surface area of the cone would of course also include the surface of the area of this circle, which is also part of the surface of a cone. And we derived this formula in class, so you understand that S is the slant height, the height from the vertex to the edge of the cone circle, and we talked about why this formula, or how to derive this formula. And so the tricky thing about this problem is we have two cones stuck together. They're intersecting on their circular part. So you have to sort of modify this formula in a way to take into account that not every piece of this formula is included in the surface of this composite shape. So I want you to think about those things and try to find the surface area of this composite three-dimensional figure, and then come back and see how you did.
Paused.
Okay, I'm going to write the surface area formula for a cone, basically just copying what I have up here. And we know that these two cones are congruent, and so you might think, well, we can just substitute all the values into this formula and then double it. But what you have to realize on this problem is surface area literally means the area of the surface. And since these two congruent cones are stuck together at the circular by their circles, these circles would not be part of the surface area anymore. If you were going to cover this three-dimensional object with paper, for example, you wouldn't need to cover the circles. You would just need to cover this lateral area. And so this part is important. This part is not included in the surface area for this particular three-dimensional object. And so we could just find the lateral surface area of one of the cones and then double it. So the surface area in this case would be equal to 2 multiplied by pi times the radius times the slant height. I'm going to say approximately, because radius is 3.14. 2 times 3.14 multiplied by the radius is given. You see it goes from the center to the edge, so that 4 is the radius. And the slant height, the distance from the vertex to the edge of the cone, is 10. 2 times 3.14 is 6.28. 6.28 quadrupled is 25.12 times 10 would just be 251 and 2/10. That would be our estimate for the surface area. And since the directions tell you to round to the nearest whole, I'll identify the 1 is in the whole. The unit place is filled in with a 1 here. The number to the right is less than 5, so we're just going to say the surface area is approximately 251. Having trouble with my writing tablet. 251 meters squared. Square meters because we're talking about area of the surface, and area is two-dimensional. Okay, I hope that helped with the homework. I'll see you tomorrow.